my hope is that these example problems look familiar to you in terms of the mathematical procedure used based on our transposing graphs that we did back when we were looking at position, velocity, and acceleration graphs and going back and forth with slopes and areas. But let's go through them just for completeness. Here, if you were given this u of x as a function of x graph, you need to know your equations, and you need to know how your equations translate to the graphs. So f of x equals negative du dx, so that means I'm taking negative slope of the tangents. So this is where the pesky negative can get in the way. If we take the slope of this first section of our problem, that slope comes out to be 15, but that pesky negative makes it a negative 15, and then of course we plot the negative 15, and technically we should have an open circle and a closed circle, and looks like we had open and closed, open and closed. And I'm not going to go through the taking of the slopes, but you can see how this plays out. We're getting step functions. When the slope doesn't change, the force doesn't change, and we have these discontinuities. They would smooth out with actual functions or with our calculus. So we have one more problem to look at here. You can pause the screen and look at this if you would like to. We have one more example problem to look at, and it's going from an f of x graph, as this shows, to the u of x graph. And again, it's a must for you to know your equations and be able to apply them graphically. So delta U, change in potential energy, represents negative the integral represents the area bounded by the function, and that pesky negative gets thrown out in front. For integration, you have to be given the initial value, which in this case we are, 4 joules. So we start, our first dot is at 4 joules, so just like we've done before, when we're calculating areas, we're playing connect the dots. But our delta values give us the change from that dot, not a specific value. So that first area equals 8, right? Base 1 times height 8 newtons. So we get 8 joules, and that pesky negative out front changes it to negative 8. So again, we don't go down to negative 8. The change, the delta was negative 8, so we go down to negative 4, and we play connect the dots. Again, I am not going to go through each and every calculation with you. Keep in mind that those areas need to show a general calculation for one of them, so you can show the greater that you knew what you were doing, and then you can just show the values for all of the others. Don't forget the negatives, and just play connect the dots, and it would be a smoother function, of course, if we were actually integrating or given a function f of x. So pause here if you need to, and that completes all of our examples.